a lot of those homework problems that I have on there are UV integration by parts, UV minus integral b du. We are not repeating that. You don't have to repeat that. So I'm going to take away some of the homework problems. I didn't finish?
No.
Okay, good. What was it?
Here I have it. The integral of 0 to 3.
Of x over the square root of x plus
Yeah.
1? Got it. All right, let me write it out. So, I think I've got all bases covered. I got to write myself a note to order two of them. Okay, so what we have here is your basic. Did I start this one?
Yeah.
Okay, so did we get to a point where this is guided? What's cool about these problems is they start to guide you in the right direction. Like, hey, by the way, you are going to use U substitution. And like, oh, cool. Otherwise, you're like, how do I do this problem? So in the real world, obviously they wouldn't guide you, but in this particular class, they guide you. So everywhere I see x plus 1, I'm going to replace it with u. However, I'm also going to change everything that has to do with x. So the next thing I'm going to do is recognize that this becomes a u. So I'm going to start to rewrite it. I have the square root of u on the bottom, but I still have x on the top and dx. So I have to solve for the letter x to replace it in terms of u. So that's a pretty easy fix here. I'm going to subtract 1 and find out that x is u minus 1. Are we okay so far? So there are two other things that we need to change, the dx and the limits, 0 to 3. So when x is 0, what would u be? And when x is 3, what would u be? So if I take this and I plug in u is equal to 0 plus 1 and also 3 plus 1, what are my new limits for this problem? From 1 to 4. This alleviates the problem of me having to go back and resubstitute back into terms of x. If I leave everything in terms of u, I'm good to go. Okay, one last thing, dx. So what I have to do is I have to take the derivative of this with respect to x and see if I can solve for dx. So what is the derivative of the letter u? It's du over dx, right? Derivative of u with respect to x. And then what would the derivative of the x be? 1, and the derivative of 1, 0. So is it a possibility for me to solve for the dx? So I would multiply both sides by dx. I'd get du is equal to dx. That's easy enough. So I'm going to bring it over here as du. Now my goal of having everything in terms of u is completely accomplished. Now I can do algebra, and then go ahead and integrate. But try to do as much algebra as possible first. Okay, so if I'm looking at this, I'm going to go from 1 to 4. Do you agree, because I have 2 items on top and 1 on the bottom, that I can rewrite it as like u over u to the 1/2 minus 1 over u to the 1/2 du? How do you feel about that? Yeah. So now I'm going to clean it up, algebra as much as I can until I can integrate. So this is u to the 1 over u to the 1/2. So what do I get? U to the 1/2. And if I clean this up, it becomes u to the negative 1/2. Now you're going to integrate. Okay. At this point, this was impossible to integrate, really tough. This is really easy to integrate. Yes.
I flipped up the u to the.
And then distributed?
Yeah.
That's fine. Does the same thing. Okay, so u to the 1/2, if I add 2 over 2, I get u to the 3/2 over 3/2. And then minus u to the positive 1/2 over 1/2 from 1 to 4. I don't have to go back in terms of x because everything, including my limits that were once 0 to 3, are now 1 to 4 because they're now in terms of u instead of x. How do we feel about this so far? Yes.
How'd you get 4 to 1?
It used to be 0 and 3 when x is 0 and x is 3. So if I plug in x is 0, I get a 1. And when I plug in x is 3, I get a 4.
Okay.
Okay. So gonna plug in 4. And then I'm gonna plug in 1. Go ahead. I thought I heard wait.
Oh, I'm sorry.
It wasn't a real wait. So 2, square root of 4 is 2, 2 to the third is 8, so go ahead, do I have, we're good? Thank you. So everybody did their thing here. This will be fun. So 16 thirds minus 4 minus 2 thirds plus 2. So 14 thirds minus 2, 14 thirds minus 6 thirds, so 8 thirds is our answer. How do we do? How do we feel? We feel good? I do have another strange question. Are there any do me a favor and do partial fraction decomposition for me, just like old times of this. You could do this. You can do this. All right, let me take roll.
Oh my gosh. So sorry.
A over x plus 1. And then what would this guy be? X squared plus 3 would be what? Bx plus c. How do we feel? We feel good? We need to know this for the midterm, yes? Yeah? Okay. Those of us that have started working on the midterm review, we haven't seen it yet, but that's the next chapter. Have you? Today, you've been working on it. You're diligently getting through that. So x squared plus 3 and then x plus 1. Don't forget parentheses around that. All right, how do we feel? Feel good. Okay. So we have 3 minus x equals a times x squared plus 3 plus bx plus c times x plus 1. Okay, now, if you can recall, let x equal -1. Does that ring a bell? Okay, so 3 minus -1 is equal to a times -1 squared. 1 plus 3 is 4, and that zeroes out. So 4 equals 4a, a is 1. How do we feel? Cool? Obviously nothing can be plugged in here. That'll reduce it to 0. So what should my next number be that I use?
0.
0 is cool. Okay, so if I let x be 0, I've got 3 minus 0 is equal to a, which is 1, and then 0 plus 3 is 3. And then if I plug a 0 here, the b goes away. Are we cool? So that's c times 0 plus 1. So 3 minus 0 is 3, and then 3 plus c, 0 is c. Are we okay? No? Did I add wrong?
No, that's what I.
Okay, good.